So I'll be your trainer for this CCNA session from today onwards. So this CCNA, this is our one of the basic sessions when it comes to networking. So I'm hoping so most of you are new to the whole networking concepts. We'll just do a quick introduction, and after that we can start with our today's session. So as I was saying, my name is Kevin. I worked in this networking field for around 5 to 6 years now. I mostly concentrate on CCNA based networking as well as cybersecurity and automation. A bit of DevNet, cybersecurity, etc., as well as CCNA based course. So uh, I worked as a network engineer and I've experienced working with defense team as well as a few MNCs over and here and there. I've taken like private sessions as well. So this you can consider as like a small session for CCNA. Here, what we're going to basically do is we're going to discuss a little bit about different networking concepts, routing, switching, ACL, setting up rules. So these are some of the major things that we'll be discussing during our sessions from here on. And we'll also find out what are the different methods that you can use to configure different types of networking devices. Okay, is it? Sorry. I think my voice is less. Just give me a second. I hope it's okay now. Am I audible?
Yes.
Yes.
Great. Thank you. So yes, as I was saying, so in this session, we are going to discuss a little bit on what are the different networking concepts, bit of routing, switching, and also how to work with different types of networking devices. Okay, so this is what we'll be doing in our CCNA session. So let's just do a quick introduction. Just give me an idea. Just tell me your name. Tell me if you're fresher or working, and if you know something about networking. That's it. So let's just quickly go ahead. Should I call names, or if you want, you can just come ahead and say. Okay, Vinay. Okay, you can just put it in the chat as well. That's also fine. If you want to say, that's also okay. Vinay working. Okay.
Yeah, hi, I'm Ranjit. I'm working as a Linux system administrator. So
Okay.
I have 10 plus years of experience in Linux system administration. I know some basics of networking.
Networking. Okay, fine. That's good. Thank
Yeah,
you.
thank you.
Yes, go ahead. What's next?
Hi, Kelvin, and everyone.
Ranjit, right? Ranjit, I got.
Hi, I'm audible.
Hey, Vinit. Yeah, you're audible, Vinit. Go ahead.
Yeah, myself Vinit, and I'm working as a system administrator, and I do have a 4.5 years of experience on
Okay,
IT industry. So,
great.
uh, yeah. So, I have done my CCNA, on 2019, long back. So
Okay,
I haven't gone into depth in my job field, so I'm recalling it back in this way. So I want to be depth, so I joined networkings.
great. No worries, no worries. We will go in depth in this session. So, good start.
Thank you.
And I can see Shubham working basic knowledge. Nahid working as project engineer, great in safety and security. And networking is new for you. Fine, no worries. We'll start from basics. So, anybody else?
Hey, hi. Myself Tahir Patel. I'm working as a
Okay.
support engineer, and I just currently doing CCNA also. And
Mhm.
yeah,
Okay, thank you, Takir. So you're starting with CCNA, which and Vaishnavi working for 2 years, have basic knowledge as per job. Okay. And Nahir, project engineer, safety and security. Divya, BCA student, so I'm guessing new to this. And Revati working as associate professor. Great. So we have a teacher. And Divya Dutt working basic knowledge of networking. Sahil, BCA students, some basic knowledge. So from what I can see, most of you have some basic idea about the whole networking, but not in depth. So no worries. So in today's session, what we're gonna do is we're gonna just start with some of the basic stuff, like what are the different network components, what are the different parts of this network and everything. And after that, we'll go deeper into this session. Okay. So we have other new student networking. Okay, you have done CompTIA, so bit knowledge is there. So those who have done CompTIA or ITIL and all, I'm guessing you will have some idea regarding this networking part. And Priyanka working as an L2 network engineer, great. So you might be having some idea about at least switches. When I'm working as networking security engineer, okay, great. So I think you have a bit more ideas on that part. Data comp certification. Okay, really got it. Okay, so I guess we can go ahead and start with our session. Anyway, so as I said, my name is Kevin. So I'll be the one who will be taking this session for you completely. And this session will be around 40 to 45 hours, depending upon how much topics we'll be covering. And it will be having both theory as well as practicals. Okay, so we'll be doing both inside our sessions. Uh, I think my screen is coming up. Okay. So sometimes we'll be taking a particular session and directly going for the labs. Sometimes we might concentrate a bit on theory to make sure that you get the idea right, and only after that we'll be going into practicals. But anyway, we'll be covering both theory and practicals on complete requirement for our CCNA topics. So this topic will, this course will actually help you to go for both practical requirements if you are concentrating for work, as well as we will discuss some kind of questions and stuff that can actually help you for your exam as well. Okay, so we'll be concentrating on both aspects because few of you might be working and need this for your work requirements. Others might be looking for certifications. So yes, let's go ahead and start. So I think you might have seen some of these slides during our introductory day. CCNA is our base course that we'll be concentrating on. And after this CCNA session, you have the option to go for specialist. So for specialist requirements, you can either take your core exam for whichever like lane or whichever uh, concentration that you want to go for. So you can security, enterprise, service provider, collaboration, data center, or DevNet. If you want to go for any one of them, you can start CCNA as the base one. And after that, you can go for the core exam for any one of this. If you want to go for professional level exam, you can take one core exam as well as one concentration exam. So that will be similar for everything. Enterprise core, security core, the service provider core, and as plus a concentration exam. Okay, so that gives you professional level certification. And if you want to go for expert level certification, again, you have to take the core exam, that is NCore, along with an 8-hour lab. So that is also common for all these sets. So DevNet, it's mentioned coming soon, but it has already started. It also has a core exam, which is known as DevCore. Okay, you can see it over here. Along with that, you can take an 8-hour lab and get the certification. So these are some of the different lanes or different departments that you can go from here, like after CCNA, enterprise security, service provider, collaboration, and data center. So let's quickly go through what are the different modules. I think that also was discussed a little bit on our day one. During our demo session. A few of you might not have been part of that, hence I'm repeating this part. So these are the major topics or major modules that we have to cover during our CCNA session. First one will be network fundamentals, where we'll be discussing some basic stuff about what are the major components of a network, what are the different aspects, like different types of devices that we use in a network, how do we establish connection, how do we enable connection, or how do we limit any kind of traffic. All these things we'll be discussing over there. Then you'll go for network access, providing access from one network to another or within a network. Then IP connectivity and IP services, where we'll be discussing about establishing connection using IPv4 or within a LAN-based connection. Then IP services like ACL, how to use this IP address to set up different forms of services. Consists of ACL, NTP services, HTTP services, etc. Then you have security fundamentals, where we discuss about setting up remote access, uh, like using SSH, Telnet, etc., those kinds of stuff. Then we go for a little bit on automation, where we'll be discussing about few topics from DevNet, and programmability and automation part will be discussed on that. For programmability requirements, my suggestion is people who know Python, it will be a great helpful. Even if not, we will be discussing our required part of like what kind of data structure everything will be using over there. And finally, portion 7 is just mentioned as lab practice. So this is common for all these different topics. We'll be having lab for all other 6 modules as well. Okay. We'll be having some close to 15 to 16 labs during the sessions. So yes, let's go ahead and start with the session. So yes, the first question that we're going to discuss is about network components. So like what exactly is a network component? Anybody would like to discuss? This is like just a base question. If anybody want to say something, you're free to. If not, I'll just go ahead. Okay, no worries. So let's say a network component, basically it refers to a device or let's say a software that actually plays a role inside the functioning of a computer network. So if you want your computer network to work, it needs different components. It needs hardware components. It needs software components. It needs like some components to actually establish the connection, like your cables, RJ45, etc. All these can be considered as part of a network component. So some of the like very common network components that you might have heard is like router, you might have heard of switch and hub maybe, and like your system, you're sitting on a system, right? That can be considered as an endpoint device. And if you are connected to the internet, that means you have an NIC inside that, that is network interface card. So that's again a hardware component that connects a computer to a network. So all these things can be considered as a network component. Some other stuff you might have heard might be firewall. So a firewall, this is again like can be a software or a hardware, which basically helps you to set up some kind of security and monitoring requirements on a network. Then you have access points, you have gateways, network cables, everything that you basically use to establish a connection or establish a network can be considered as a network component. So while using this network component, what are we creating? We are creating a computer network. So this term network is basically used in many different aspects. In some examples, the networks are social networks, phone networks, television networks, neural networks, computer networks, etc. So when it comes to our case, a network is basically a system of connected elements. So you have multiple elements or multiple systems or multiple devices that are connected together or brought together to work simultaneously with each other or work in interconnection so that they are able to either share something. It can be data, it can be voice, it can be video, it can just be some kind of text or some kind of value. So whenever multiple devices are able to exchange data and establish some form of connection between them, you can consider that as a network. Okay. So even your computer system, and if you're working somewhere, if you have multiple systems connected together, that's a network. And TV network, like if you have cable inside your home and you're getting that connection from somewhere, right? That can be considered as a network, satellite network, etc. So all of these things are different types of networks, but we will be concentrating more on computer networks and LAN-based connections. So that is what we're going to discuss inside our CCNA. So up to here, I don't think I have mentioned anything that is too hard to understand. I hope all of you got it. Yes. In case of any doubts, feel free to ask. Okay, you can come off mute and ask, or you can just mention in chat. Anything is fine. We'll be happy to help. Okay, great. So yes, let's go ahead. So when it comes to networking devices, let's see. Um, Work devices. I hope you can see my screen. Can you see this whiteboard?
Yes.
Okay. So yes, network devices. So there are multiple types of network devices that you can discuss. So this can be considered as mainly, so one is endpoint devices, endpoint devices, and the other one is intermediary devices. So these are basic two types of devices that we have or that can be considered as network devices. Okay. So when it comes to endpoints, in context to like our form of network, endpoints are basically your end user devices. So this can be your PC, this can be your laptop, can be a tablet or mobile phone, or some of you, if you're using gaming stuff like gaming console, can be considered as a endpoint. Or even like if you have a smart TV or something like that, and if you're connected to Wi-Fi, your television can be considered as a endpoint device. So this but when we are going a bit more deeper, this can be like for networking aspect. If you're going a bit more deeper, we'll consider our PC, a server can be considered as an endpoint device because uh, it's at the end, basically. Okay, and all the data that are stored inside that server, you'll be using. So just like a PC or something, you can consider the server also as an endpoint device. And what else? Network printers, network cameras, like CCTV, etc. All of these can be considered as an endpoint device. So basically, any device that we actually use directly. Okay, so for example, PC, consider PC. You'll be accessing that PC directly from your end, right? So that is a endpoint device. Camera, it is at the end of that network. To that, nothing else is connected from that particular point. So that can be considered as an endpoint device. Whereas when it goes to intermediary devices, these are basically the types of network devices which help you to connect to another device. Okay, we won't be using this particular device for its requirement. We are using that intermediary devices to connect to our endpoint device. Okay, they just perform, uh, their performance will be dependent upon the connection to that endpoint device. Okay, so for example, if you're using a switch or if you're using a router, etc., we won't be like working on that switch or router. Instead, what we'll be using that switch or router to connect to another computer or connect to another and printer or maybe to a camera or something like that. Okay, our requirement, our output and everything is coming from that endpoint device, and this is just the path through which this data is being sent. Okay, so those kinds of devices are known as intermediary devices. Some of the examples are switches, routers, access points, wireless devices like modem, etc. Yes, hubs also can be considered as a uh, intermediary device. Hubs, bridges, and even firewalls can be considered as a intermediary device, because whenever a connection is coming from outside to your internal network, you have this firewall in between. Even though it's not just used to connect between that two devices, it's used in between to filter the kind of request, which means it is part of the intermediary devices. So these are some of the intermediary devices and some of the endpoint devices. Okay, I hope you got an idea on that. So let's go back. So practically, I think you got an idea about network components. You have endpoint devices, you have intermediary devices, and you also have network cables. So that also you can consider as intermediary devices, not actually device, but intermediary component. Okay, so let's go. We discussed on network components. Next, yes, routers. So router again is like one of the most important uh, intermediary device that we have. So this router is a crucial network device that operates with the layer 3 network layer. Okay, layer 3 or network layer. So this is part of your OSI model, and its primary function is to forward data packets between multiple networks. So we'll get to that. So before starting that, let's say we discuss a little bit on OSI layer. No, we can discuss OSI layer later. After we discuss switch, we can go to OSI layer. So right now, let's look at a router. Okay. So let me minimize this. So yes, router. Anybody has something to say about router? If yes, feel free to say. Okay. Any ideas on what this router actually is?
It's a communication between two networks.
Yes,
So
that's
basically a gateway to the outside internet, I think.
also right. Correct.
Just communicate
So
to different network. Maybe I'm correct.
you are right. Yes, correct. So all of you said like different functions of this router, and all of them are absolutely right. Okay. So when you're putting it in a simple words, all you can just say is like one of you said, router is basically a device used to connect to different networks. Okay. So how do we identify these two different networks? It's basically simple. Each network should be having different sets of IP address. Okay. So for example, imagine that you have a network here. So this is a switch, S1, and to that you have a PC, three PCs connected. So it has an IP address of, let's say, 192.168.1.2. Here you have 1.3. Here you have 1.4. Like 192.168 is common. Okay. And 1.2, 1.3, 1.4. And here you have another switch onto which you have again three PCs. This has, let's say, 192.168.2.2, 2.3, 2.4. So just by looking at it, you can understand both of them are two different networks. So understanding requirements, you can just mention /24. We'll discuss on what that actually means later. So when /24 comes up to here, you consider as a network ID. Okay, so each IP address and everything has a particular subnet mask. Okay, if I start explaining that right now, it will be a bit confusing. So let's remove something. Just consider this. At the moment, just consider, yeah, that's enough. So this is 1.2, 1.3, 1.4. Here you have 2.2, 2.3, 2.4. Okay. So just assume these two are completely different networks. So this is first network, and this is another network. So if we are establishing connection from this switch to this switch, the connection won't establish. The reason is simple, that the switch is a L2 device, and this is switch 2, also an L2 device, which is layer 2. Okay, whereas this IP address that you see over here is something that work on L3, that is the network layer. Okay, so switches don't have the option to send an IP address from here to here since it does not manage or work with IP addresses. It doesn't have the ability to work on that. Whereas we have L3 devices such as routers. So if you are adding a router over here, R1 and R2, what basically happens is this request that is coming from this device to that device goes to the switch forward into this particular router, and router, inside router, it has the ability to manage L3, which is an IP address. It will be able to identify where this packet has to go or where that request has to go and forward it to the correct network or correct destination. So whenever you're dealing with these kinds of IP address and all, switches don't have the ability to manage those IP address. Okay. Hence, when we have multiple networks, it has to use this router to forward that data. At the same time, like if this 1.2 want to communicate with 1.4, you don't need this router. The reason, because when we are trying to connect from this device to this device, it not only uses the IP address, it also uses something else known as MAC address. Okay, somebody's coming up. Yes, correct. You mentioned it right. So it also uses something known as a MAC address. A MAC address is basically the device identification. Like it is a hexadecimal value which is unique for each devices. Okay, so if this device has a MAC ID, it will be unique to that particular ID, and that details will be stored inside this particular switch. And switch has the ability to communicate within a network. Okay, so the difference you can just make note right here itself. Router, it has the ability to communicate between two different networks, whereas switch is used to communicate between devices within a network. So router, two different networks, switch within a network. So that is the main difference that you have to know. If somebody asks you what is the difference between router and a switch, you go ahead and say router works like router helps to communicate within two different networks, and switch helps to communicate within one single network. And router works on layer 3, that is network layer, and switch work on layer 2, that is terminal layer. We will get to what are the different layers after this. We'll discuss a bit on OSI layers as well, though you'll get an idea about what is L2, L3, and etc. are. So this part you got, right? How to work between two different and within a network. Router for two different and switch for one single layer. I mean, one single network. Are we clear on that?
Clear, sir. Clear.
Yes.
Clear.
Nahid,
Yeah,
yes,
Kevin,
that's
I
it.
have one doubt.
Sure, go ahead.
Hello.
Yeah,
Yeah.
sure. Go
So
ahead.
when let's say so
Hello. Am I logged out or is somebody saying something? Because I'm not able to hear anything.
No, sir. We can also not hear them.
Something might be audio issue.
If somebody was saying something, please mention that in the chat so that uh, like I can answer to you if you're having some network issues. Okay, so another question, Nahid. Okay, can we say that router is a bridge between two different devices? So that is a good question. The only thing is, don't use the word bridge. Deepak, uh, is my audio clear to others?
Yes, sir. Clear, sir. Audio.
Okay. Just
like let's say if your system 192.1.3, so the packet.
Okay, somebody was saying something, I guess. Please mention chat.
Kelvin, one more thing, like in even in layer two, communication between one single network,
Yes.
even layer two uses op table of MAC, right?
Uses ARP table. Yes,
Yes,
correct.
ARP table for MAC also, right?
Correct. So
When it
in
comes
Switch,
to
we have a table, but
yes,
it won't be able to manage IP addresses over there.
yes,
That's the
yes,
only issue.
that
Yes,
usually
correct.
comes on ICMP level, like, if I'm not wrong, on layer three.
Correct, yes.
Yes.
Okay. Okay, so let's go ahead. So what I just mentioned is just the basic function of the router. Okay, so that's don't think that is the only function of the router. We have multiple functions over there. Well, I just joined. I'm from Nepal. Okay, Deepak, that's fine. But I don't think there is a sound issue. Just check your audio side. Okay, no problem, no problem. So yes, coming back. So as I was saying, that's just the basic function of routing. That's not just the only function. So eh, give me a second. I think people is not still able to hear anything. Just give me 1 minute, guys.
Sorry, my Wi-Fi got disconnected. I have connected over.
Okay.
Okay.
Uh,
So I was asking one doubt. Yeah. So regarding that packet, uh, this thing. So it will go through the router, or it will directly the packet will be
so
forwarded from the
like
switch.
what I have to tell you is I didn't hear your question completely. When you just started, it just went off. I I couldn't
Oh,
even
okay.
hear
Sorry.
it.
So so let's say that like a PC has this IP address 192.168.1.1, and it try to send packet to 1.2.
1.2. Okay, which
Okay.
means in between you just
Yes.
have a switch.
Which is in the
Correct.
same network.
Okay,
Same network.
fine.
So in this case, the packet will go to the router, or within the switch only it will.
It won't have to go to the router. Reason is because when we are trying to connect with inside the same network, inside
Okay.
that particular packet, it has IP address, but at the same time, it also has the source destination of MAC address as well. So when
Okay.
it reaches
Hmm.
this particular switch, it won't check the IP address part, but it will check the MAC address part.
Hmm.
Okay,
Okay.
and this switch will be having the MAC address of this particular device.
Hmm. Hmm.
Whereas if
Okay.
you want to connect to an external network,
External network.
uh,
Okay. 2.1 or
yeah,
something.
let's 2.1. Consider it's 2.1. MAC address
Hmm.
of this device is not available here. Only this switch has
Yes.
that. Hence, it won't be able to
Okay.
forward it.
Hmm.
Okay, you got that part?
Yes. Yes.
Okay,
Got
so
it.
within the network, no issues. It will be able to identify. Outside the network, we need router.
Router.
That's the
Okay.
reason.
Okay. Got it.
Okay,
Thanks.
great. No worries. We'll do that as a practical also. Okay, great. So everybody is able to hear. So as I was saying, some of the extra functions of routers that we have that, so again, these are the major functions that we have. The first one is packet forwarding. So let me just go ahead for that. Okay, again, we have like few more questions. Like, just give me a second. Monty, okay. Sir, if we open a run command, we type IP address. I'm guessing you're talking about ping. So in that case also, even if we are mentioning just ping, when the packet is being created inside your system, it not only takes the IP address, it also takes the MAC address of your device. Because MAC address you don't have to mention inside the system. Whenever a packet is being created inside your system, it takes something known as the fingerprint of your system, which consists of your MAC address. Hence, you don't have to mention that MAC address. Every packet will be having the source and destination MAC address over there. When it reaches that particular device, because this device will be taking all the required MAC address over there, it has a complete table on that. So you don't have to specifically mention that MAC address. And others AG. So if we use only one router in between two different networks, can they communicate with each other? Yeah, sure. We can use one single router. I hope you mean something like that. R1, here you have a switch. Here also you have a switch. 192.168.1.0, which means here you have 1.1, 1.2, etc. And here you can set up 192.168.2.0, that is 2.1, 2.2. I hope this is the setup that you mentioned, the others. If this is what you mentioned, definitely yes, it will be able to work. Because here you have the option to set something up over here. This is your default gateway. We will discuss that during our practicals as well as when we're discussing more into routing. Okay, no worries. So yes, with just using one router, you have the option to set up multiple networks over there. Okay. Great questions for the first day. I'm actually impressed. So yes, let's go ahead. And as I was saying, some of the extra functions of the routers. So first one is packet forwarding. Okay, so packet forwarding, let's say a router basically examines the destination IP address of the incoming data packet and forwards them to the appropriate next hop router for the final destination based on the routing tables and algorithms. So for example, let's say if you have a router here and you have a router here, you have a router here, and here you have a network, let's say 92.168.2.0. Here you have a network 192.168.1.0. And here you have a network 192.168.3.0. So these are your three networks that you have right now. So imagine from this network, I'm sending a package, and inside that, I have a source IP will be this 192.168.1.0 or 1.1, something like that. Destination is 192.168.2.3. So that is the destination IP address I mentioned. So once it reaches this router, let's name it R1, R2, R3. When it reaches R1, what it basically does is it go open this packet up and it checks the source IP address, destination IP address. So it finds 192.168.2.3 over there. So it has to decide. So based on that particular IP address, it will be having a routing table in which it will store details. So if I want to send to 192.168.2.0 series, I have to forward it to R2. Similarly, if I want to send to 192.168.3.0, I have to forward it to R3. This kind of a table will be present inside R. So it finds out the destination is 2.3. It goes into the table, find out the 2.0 series, 2.1, 2.2, 2.3, 2.4, etc. I have to forward it to R2. So it just forwards the same to R2. The packet will be forwarded to R2, and R2 is directly connected to that network and it forwards to that particular network. So wherever that PC is, the packet will reach that particular PC. So this method of forwarding the packet from one router to the next router is known as packet forwarding. Okay, so that is one function of our router. Another thing is something, okay, so basic thing, it's known as routing, the name itself. Okay. Thing. So I'll just explain the basic over here. So imagine here, we have a router here. Let's consider it like this. Okay. And I want to send a packet from this router through that router. But let's say R1, 2, R3, R4, R5. So I want to send one packet from R1 to R4. You have two paths right now. I can go through from here to here, then here, then here. That is one option. Or I can send through here. So I have two paths right now. So the process of decision making by R1 to choose whichever route it has to follow. So it can choose this route. It's completely up to the router. It can choose this route as well. So depending upon what kind of protocol that we're using, this router will be making that decision. We have different types of routing protocols, static, dynamic, etc. We'll come to that. So before that, so let's assume this R1 made decision to send the packet to R5 and from there to R4. Okay, so that decision making process is known as routing. Okay, sending or creating a route inside this network to send a data packet. Okay, so that is another function of, let's say, our routers. And there are a few other stuff like subnetting, which basically divides one network into two, and network address translation, which basically convert public IP address into private IP address, etc. All these are different topics we'll be discussing later. Okay. While we're actually going to learn about the practical side of it, we'll discuss on network address translation and network segmentation, etc., like subnetting and all. We'll discuss during that time. So these are some of the major functions of a router. And each router has like a specific set of components within them. So let's go ahead and see that. I hope nobody has any doubt till now. In case if you do, please feel free to ask. So, okay. So, yes. Next is the different types of router components. So each router has like multiple components as part of it. So just like any computer or any device, like you have a CPU. So obviously we just mentioned this router has the ability to make decisions, right? Whether it has to do any kind of computation or anything, you need a CPU. So that is your first component, hardware component. Inside your router, you have a CPU. Then you have RAM. So if you want the CPU to work, you need some kind of random access memory so that you can use that particular memory to do this computation. So this is your brain. This is your like volatile storage where you do all these different, uh, let's say, computations. So you have a CPU inside your hardware, sorry, inside your router, you have a RAM. Next, you have a flash memory. So this flash memory is basically where you will be having your uh, configuration, base configuration, and everything is stored. Okay, so each of these devices, each of these routers or switches or anything like that must be having a set of configuration for that router to work in a specific way, right? So all this configuration and everything will be stored inside this flash memory. Okay, you have CPU, RAM, flash memory. Finally, you have interfaces. So interfaces is basically the ports that you connect into. So you already mentioned it here as well. You have different ports and interfaces. So depending upon what kind of speed or what kind of bandwidth that you need inside your router, you can set up different types of interfaces. There are Ethernet interfaces, serial interfaces. Then you have fast Ethernet, gigabit Ethernet, etc. So all these are different types of interfaces or ports. So if you want to see the actual interface of port, just take your modem. In behind that, you can see RJ45 ports, right? That can be considered as an interface. Okay, this will be named based upon the type of interface that you have. For example, for fast Ethernet, we name it as FA0100, etc. Similarly, gigabit Ethernet, you have GE0100, etc. So if you're actually seeing a router or switch, go to the back of it, you'll be able to see like multiple set of ports. Depending upon the device and depending upon the modules that you have over there, number of ports will vary. It mostly go from 4 to 48. Okay, so that's the basic range for a device interfaces. Then you have your software components. It consists of mainly two things. One is your operating system, the next one is your firmware. So firmware, you don't have to worry much because it's already set up on that device when you get it. Then you have your operating system. So depending upon what kind of device that you use, that may vary. So for example, you have some of the major Cisco-based operating systems are Cisco iOS, Cisco iOS XE. So let me just write it down 1 second. Yeah, some of the different types of operating system that you have is Cisco iOS, OS XE, OS XR, and XOS. So these are some of the most common types of operating systems that you have. Okay. In case of Cisco, for others, we have other operating system as well. Because Cisco is not the only vendor. You have like Dell, then you have HP, etc. Like these are some of the major ones. And depending upon whatever different device, you have different types of commands to use that as well. Syntax will be a bit similar, but the commands might differ. Okay. These are some of the operating systems that you have. And what else? Okay. Since we are discussing about routing and routers, there are basically two types of routing methods. So these are static as well as dynamic. So static meaning it's simple, like we tell that particular network or that particular network device how to send the data packets. For example, am I going too fast? Are you able to understand?
Yes.
Able to understand. Okay, fine. So, objects. So when I'm talking about these routing methods, as I mentioned, we have static and dynamic. So first, let's look at static. So what is the static routing? Basically, like if you have this router over here and you want to send a packet from this router 1, router 1 to router 4. Okay, using static, we can actually tell this router to take whichever route that we want. Okay, we can actually decide the route and tell router 1 to take that particular route. So that is the plus point of working with static routing. Okay, so for example, if you can see this is the easiest way, right? Just one hop. Whereas here you have to go through two routers. At the same time, if you want your router to take that particular route, you can ask it to do that. So for example, in this case, like if you are telling this router 1, if you want to send a packet from router 1 to router 4, you have to send it over here and from here to here. Like if you are telling this router 1 and router 5 to do that, it will do that without asking any questions. It will forward directly to router 5 and from there it will be sent to router 4. Okay. At the same time, while setting up static routing, if you are asking it to do, send it the other way, like to 5. If you're asking it to send to router 2, router 3, router 4, it will do that. It won't even consider this path, even though it is easier. That won't be considered. It will just forward the packet to R2, from R2 to R3 and R3 to R4. It will reach through that particular path. So whenever you are working with static, it's completely up to the administrator. Whatever you say goes. No questions asked. Okay, so that kind of a setup is static routing. Whereas dynamic routing, the difference is that depending upon the type of dynamic routing or dynamic protocol that you set up, it can change. Okay, it will. So let's quickly look at an example here. Routing. So, for example, if you have a system, similar system, so you have R1, R2, R3, R4, and R5. Okay. You want to send a packet from R1 to R4, but you have set up one of those dynamic routing protocols here. So let's see what are the different ones that you have. You have RIP, OSPF, EAGRP, and BGP. So let's consider RIP. Okay, so the if you're considering RIP, what you have to do is you have to access all these network routers, open all these routers, and install RIP over there. Or you can just give the RIP command, and it will be enabled on all these different routers. So once you do that, then you don't have to say which route to take. All you have to tell this router is send a packet from R1 to R4. Depending upon that RIP protocol, it will automatically take it through this route. The thing about RIP is that it goes through the shortest path. I mean, shortest number of hops. So here you only have to jump twice. In case of this, you have to jump 3 times, right? Because you have two routers in between. So it just takes the shortest path and reaches the destination. So similarly, you have different dynamic routing. So the thing about dynamic routing that you have to know is you don't have to decide the path. The path will be automatically decided by these different types of dynamic routing that is mentioned over here. All you have to do is establish or enable these protocols on the required routers, and the path and everything will be automatically decided by the routers. You don't have to tell it anything. Okay. So consider this option, like you have 100 routers over here. Right. So imagine that, okay, you have 100 routers, like a lot of routers. Everything is connected somehow. If you're setting up static, the problem is if I add a new router and connect it something like this, I have to go to each and every router and tell it there is a new router, you have to connect through this router. If there is a new router, you have to connect through this way. And to this, I have to tell you can connect through this way. I have to go to each and every router and tell this. Whereas if I'm using dynamic, all I have to do is add the new router, tell it use RIP or use OSPF, and I'm done. It will automatically be identified by the other routers, and everything is done completely by itself. You don't have to go to each and every router asking it to connect to that particular route. Okay, so that is the plus point of using this dynamic routing protocol. So depending upon which protocol that we use, the path that it takes to this particular location can also change. And another plus point is that if you have something like this, and if this router just fails, what happens is that it automatically changes the route. You don't have to mention to this router to change that route. Whereas in static, it doesn't have the option to change the route. Whatever packet is being sent through this will just fail. Okay. So static and dynamic has its own plus points as well as minus points. Depending upon your requirement, you have to make the decision which one of these protocols that you have to establish. Okay. So the major ones that we are going to look into is static. We'll look definitely. Out of dynamic, we are going to look into RIP, OSPF, and EIGRP. BGP is something that we use for internet requirements. Okay. All the other ones are LAN-based connections. So I hope all of you got a some basic idea on network fundamentals regarding routing, a little bit on the types of network components, etc. So now we have 5 more minutes. I'd like to use this as a doubt clearance part. So anybody has any doubt, feel free to ask. ISP level, yes, L3 ISP level, we use BGP, correct. Beneath that's a good question. So to establish connection between multiple networks between like completely different locations, we use BGP. And to put it in the most obvious simple way, BGP is used for internet. BGP is the protocol that we use for internet. So for basically connecting between all the devices. Okay. So that is the main use of BGP. We will be discussing a little bit on BGP, but not on practical levels.
So will we have the class at the same time tomorrow?
Yes, from now on, daily, 9 to 10, we have the session.
Where do we get the credentials, sir?
Oh, you're not given the credentials yet.
I mean, I'm
So-
not given. I don't know about others.
So how did you get the link today?
I have a connection, like I have a number with a manager or something, and then she gave me the link for today's
Okay.
class.
What about the others?
So I have got from through email,
You got through
but
email.
I don't have any credential. Yes, yes.
Sir,
Only link
I
only I
have,
got. No.
Sir, I
yes,
also
only
got
link.
Only link.
through
Nobody
WhatsApp.
has.
I have got all the links and access to the labs, all the stuff.
Everything is given to you.
Yeah, yeah.
Okay. Fine. Sorry, who said that? Who got the links? I
Sir,
couldn't see you. Okay, so few of you got it, few of you haven't got it. So what you can do is, some of you have this connections with your team, right? So let me see. I'll give you a number. Those who doesn't have the credentials, please contact that number. Okay, everyone in meeting. 8130.
Sir, please tell about the career scope after completing this course.
Okay, yeah, definitely. One second. I'll just mention. So I'll just add a number over here. 820.5 370. Okay. So I added a number over here. Just try to ping that number via WhatsApp and you can request for your credentials. Might take a couple of days. Until then, they'll be sending you the uh, links. Okay. Not everyone, you won't be able to get it tomorrow itself. Probably within this week, everybody will be getting the
So,
credentials.
sir, how do we join tomorrow if we don't?
Like the same way you got the link tomorrow, also they'll be sending probably.
Okay, okay.
If not, just contact them. Okay, so you can just ping this number if you don't get the link or credentials. The number I've added over here in the chat. Please save it. Yeah, study materials and everything is already uploaded inside our portal. You'll be able to download it over there. And before leaving, somebody asked me about the career options after this course. Definitely, you have like after CCNA, you'll mostly be able to join in as a NOC network engineer or somebody who is basically able to set up all these different types of uh, like you'll be able to completely manage all these networking devices. Okay, so most cases you'll be able to join in as an L3 or L2 engineer if you're a fresher. But if you're already working in these kind of levels, my suggestion is go for the certification after this. People who are currently working in L2 or L3, go for the certification. Pretty much you'll be able to go up to an associate level yeah, in a network-based company. Network engineer is the base role that will be concentrating inside a CCNA-based session. Okay.
Hello.
And yeah, please go ahead.
Yes, sir. I have a small doubt. After completion of this class, can we would
Sure,
be we would be able to configure real-time devices?
Definitely, yes. That I can assure
And
you. Not just, yeah, not just working on existing devices, you will be able to like set up a device from scratch. That I can assure you.
Okay, sir. Actually, I just wanted to teach my children, my students, that how to set up a device from the scratch. So I thought I will learn this in this, so I joined this class, sir. Now,
Oh, definitely, no worries. You'll be able to do that.
yes, sir. Thank you, sir.
You'll even start from setting up basic connections on the router, and you'll also learn how to access these routers and everything from your own PC, which you have in a completely different location. Establish SSH, telnet, any kind of connection that you want. Set up
Yeah.
the required credentials over there. All of this, no worries. We'll be doing that as lab itself, not just theory.
Yes, sir. Sir, how much is the cost for the CCNA certification? Can we get any discount in that?
Oh, that depends up with the sales team. I'm not familiar with that part of it. You might have to contact the number I gave you. My
Okay.
part is I'll be just taking the session part, okay? The other
Okay.
thing is completely with them.
Okay, sir. Okay, sir. Yeah. Okay.
Sir, what time tomorrow, like
Same time, same
audio?
time. Our
Yep.
time will
No,
be
no,
from 9 to
recorded. Uploaded at what time, sir, tomorrow?
when this session is uploaded and you'll be able to see. That's the question.
So when? Tomorrow at what time, sir? I'm
Probably
asking.
towards noon it will be uploaded. Somewhere around 2 o'clock most. Okay.
Means tomorrow morning.
Sorry?
Tomorrow morning?
Tomorrow noon. Around noon it will be uploaded mostly.
Okay, okay. Okay, sir. Thank you.
Sir, because I would also have to rely on uh, the the recorded videos because I found a job. That's why I cannot attend live, sir. That's why.
Okay, okay, fine, fine. So those who are not able to join in, try to go through the recorded videos. So what I'll say
Yes, sir.
is, few days I might say that tomorrow, like if I'm already prepared for the lab earlier itself, I might say that tomorrow you have a lab or something like that. I'll
Yeah.
also mention what lab that is based on. So if any of you have any doubts regarding those labs, try to join in live. Okay, during
Okay,
those
sir.
days at least. So you're
Okay.
working night shift.
No, sir. I'm actually in US, right? So
Okay, sorry.
it's
So it's morning
so
for you
that's why.
there.
Yeah,
Okay, okay, got
it's
it.
12:33 now.
Okay, understood, understood. That's understandable. Got it.
Thank you,
So
sir.
preferably, most of you try to join in live. Those who have no other options, feel free to check the recording. The reason I'm asking you to join in live is nothing but when I'm discussing something, uh, you might get some doubts on that particular topic. So only if somebody is joined in, you'll be able to, discuss that part. So others might not have your doubt. Okay, so preferably if you are joined in for that particular session, you will be able to clear it right away. That's why. Those who and Adil, I think if you don't have any other option, feel free to go through the recordings, but
Yes,
preferably
sir.
go through it the same day itself.
Yes, sir. I would.
Great, that's good. Anybody else? Okay, I guess not. So anyway, thanks a lot for joining in for today's session. Hope to see you tomorrow as well. So good night, guys. You guys have a good night. Bye.
Bye, sir. Good night, sir. Night.
yeah, good
Good night,
night.
sir.
Have,
Good night.
Nice, sir. Thank you.
thank you.
Good night, sir. Thank you.
Thank you, sir.
Thank you.